And now it's time for the minigun. We have two events, minigun fire and minigun fire release. First, the minigun fire. Checking the weapon will fire condition, checking the ammo. If we don't have any ammo, checking auto switch weapons logic. Here we're setting minigun shooting state to 1. This is necessary for the automatic shooting logic. So this means we are shooting. We're also setting weapon will fire to 0, as always. And next we are playing an animation montage. I have two setups available. This one on top is using standard animations without animation montage. So if you want to use this logic, it can be set up this way. Sequence. We can test it. Everything works perfectly. We play the first part of the shooting animation, well, the animation shoot 1. After the delay that covers this animation, we check if minigun shooting state is still 1. This is a conversion from an integer to a boolean. It is the same as saying equal to 1. This is the same thing. And then we play the animation that we need to loop, and we check looping. The loop will break when we play another animation for the mesh. So these are two separate animations. Let's take a look at them. So this is the beginning of the shooting. And then the minigun shoot 2 is the part that will loop. And then minigun shoot 3 is the end of the shooting. Let's go back to the logic and set it back to our animation montage. And let's take a look at the montage. It is right here in the same folder. Let's open it. And now you need to select this here and then click here, and it becomes highlighted with blue. And now this part of the animation will be looped. As you can see, only the second part is looped. So as you can see, you can have a full animation just in one file, and then you can add a section inside your one animation to be looped. So if you add another section, you will define just a part of the animation to be looped. As you can see, only this part is looping. Let's go back to our logic. So next we are spawning sound attached to the minigun. This sound will be destroyed when we release the fire. And here we will destroy the sound that is played on fire release. This is the sound of the barrels slowing down the rotation. So after we have released the fire, for about a second or two, we have the animation for the slowing down rotation happening and the sound. The animation will be overridden by this when we hit fire again. However, the sound will not be overridden automatically, so we have to destroy the component. First we check if this is valid, so if the sound is actually attached and that we need to destroy it, and then we destroy the sound, the component. And then we go to a sequence of events. First, we're setting our minigun ammo, we're subtracting 1 from the current value. And then line trace by channel. Same as before, a bit extended and just a bit of a spread. So adjusting these values, we can extend, we can increase the spread. Let's see. As you can see, we have a bit of spread now. So next, we check the return value. We get the hit results. Like always, we apply damage. Check if the target is simulating physics. Apply impulse at location, minigun FX, everything like in the previous weapons logics. However, after it, we are going to the loop. This delay represents the fire rate. So after this delay, we are checking if minigun shooting state is still equal to 1. And if we still have some ammo left, let's see where the branches go. In case both of the conditions are satisfied, that the shooting state is still 1 and we still have some ammo, then we have this loop. We arrive in the beginning of our shooting logic, of our line trace logic and damage application. We also spawn the minigun shell, of course. We spawn the emitter at the flash socket for the flash, and we make noise. So this is happening until, for example, we run out of ammo. Once we have no ammo, we go the other way. Here is the minigun release fire. It can be triggered by releasing our left mouse button, and this will set the minigun shooting state. So this checks if the minigun shooting state is 1, and then if it was 1, then it sets it to 0. By setting it to 0, it will break the shooting cycle here. It has to be connected in the very beginning of the logic, because the loop can be broken by the absence of ammo. So when we have no ammo, we still have to set the minigun shooting state to 0. And here we play our animation for slowing down the rotation of the barrels and spawn the sound attached. And then destroy the sound for the shooting. Let's take a look at this sound, by the way. You can hit browse, or we can go to minigun sounds. All of the sounds that I use got sound cue associated with them. You can create one by right-clicking, create cue. Let's open this one, the minigun shoot part 1. If you click on the output, you can see some options like volume multiplier and pitch multiplier. If we click on the track itself, there's this option for looping. So this sound is looping when we shoot. And it has to be destroyed when we stop the fire. The hit FX is the same as the previous weapons. So to recap, we have a cycle that can break if we have no ammo left, because during this cycle we subtract 1 from our minigun ammo each time this happens. And every time the logic ends, we're checking if we still have any more ammo. When we have no ammo left, the cycle breaks and it goes to our release fire logic. Or when we hit the input for minigun fire release, we set the shooting state variable to 0, which breaks the cycle. So when we hit fire, we set it to 1, then when we release the fire, we set it to 0. Also, I have this adjustments to spawn transform for the minigun shell going on here. So normally we would have get socket transformation of the minigun with the name minigun ammo socket, right? Normally it would be connected this way directly. However, we can get this for some reason Ctrl-Z does not want to cancel this action. So let's connect it back this way. So the return value of the socket transform, we can break it. If we drag and type break transform, we get this node. It returns location, rotation, and scale of the socket. Then we break the rotator the same way and get X, Y, and Z, which is roll, pitch, and yaw. And here I am adding a random float in range. And then we make rotator. And then make transform. And then connect it to the spawn transform node. This adds a little bit of randomness to the direction of the shells coming out of the minigun. Also, you might notice that this spread is arranged a little bit differently from this. However, the end result is the same.